Good morning, everyone. Good morning. Welcome to the session. My name is Amir Dabirian. I'm the Vice President for Information Technology at Cal State Fullerton. I'm here with our Associate Vice President, Berhanu Tadesse. We're going to bring you this presentation on robotics and student engagement. We're going to have about 35 minutes of a presentation. It's going to be very hard for me to stay at the podium, so they have told me to stay put. It's very hard to do so. So if I moved around, you guys kind of guide me back to the podium. So I will try my best. It's very hard to do that. So, I've been teaching for 35 years. So when you teach in the classrooms, it's really hard to stay put in one place. So I try my best. We want to start just telling you about Cal State Fullerton. Some of you guys know about us. We are founded, of course, in 57. We have about 40,000 students, about 110 degree of programs. We're 44% underrepresented. We're about 67% in financial aid. And we have 54% first gens. So, and we are listed by U.S. News and World among the top nation's most innovative schools. So I'm very proud of that little bit piece at the end of this. But we also, when we talk about those three, is because we call them triple opportunities. We have a lot of students that have all three. So they're underrepresented, first gen, and they're on financial aid. So we are keen at how to bring those students to success. I want to talk about first, we just came out with a new strategic plan for the campus. And it has 4 goals. Very easy goals, what I call them. Number 1, we want to have a transformation experience for our students. How do we be transformational and kind of have the leaders of the future? And number 2 is how do we get them across the finish line? How do we get them to student success moving forward? Number 3, how do we bring the right people in? It's about how do we keep the right people and bring the right people in. So it's about how do we do recruitment, how do we bring a diverse faculty and a staff, high quality. Because it's really hard, there's a lot of competition out there, how do we bring them in? Number 4 is all about money. How do we do fundraising? How do we really be the resource contention? How do we have the fundraising and financial infrastructure of the campus? So those are our 4 goals. We just came out in 2019. This is 2018 to 2023. So we just came out with a strategy plan for the campus. Our IT, information technology, our divisions have also 4 goals that kind of aligns with those. We're actually transforming it to be even more aligned with those goals. Our 4, number 1, we are aligning ourselves with student success. Number 2, we're looking at innovative technology. Number 3, how do we bring organizational excellence to IT, same as an institution, to have an agile governance and be able to move the institution forward. And number 4, of course, we want to have dynamic and really secure infrastructures. How do we really take our space, use the cloud efficiently? And I call it efficiently because moving to the cloud is a journey for all of us. It's just like going to outer space. We were talking about how we get to outer space in a previous keynote, or how do I go to the bottom of the ocean? So I don't know which one it is. Do I go to outer space or in the ocean? But again, it's the concept of being built an agile infrastructure moving forward. So given that and our new demographics of our students, as you know, we have lots of centennial coming to our campuses, right? Our digital natives, what we call them, it's also millennial or centennials. 25% of the populations are centennials or I generations that really need, how do we bring those people in? How do we really bridge a gap between our institution and our students? They talk about transformational, how to really have a student success in a different ways that is not the old traditional ways, right? How do we provide services differently? So we have a large student population of 40,000. We actually, we have a city north of Fullerton called Berea. We are actually larger than the city of Berea. So when you're looking at, the populations, it's a city. It's a city. How do we provide a really service across the city? And, we have resources, staff, and, here at CSU, when you're looking at CSU, we are we are always resource strapped. And how do we really look at that faculty staff resources and also budget resources to bring it in? And again, we wanted to look at the students, engage them differently. So this is a lot of challenges for us looking at the learning ecosystem. The old fashion of doing things, now I want to have 20,000 steps for you to do step one. When you get to the campus, you go through these things. It was really interesting that at the beginning of the semester, our registrar sent something to the campus that I've called my director of enterprise resource planning, and I said, I never want to see that email go out again another semester. And I'll tell you what the email was. Email was that in order to do administrative drops, we want you to go to our ERP system and print the roster. Then use pen, which is a taboo in IT work. Use pen and cross out the students in the roster. And then we want you to sign it, handwritten signature, and turn it over to the department secretary so the department secretary can process. So I want to tell you, I didn't think the blood pressure can get to 250 to 300. I thought there was a limit to blood pressure. And my blood pressure got that high that single day. So I talked to the president, I talked to the registrar, I talked to the campus. I said, we're never going to send a memo like this again, entire campus. What is our digital native think about when we send something like this to the cross campus? And this is not happening to us, it's happening across the nation to everywhere. These processes that are high cost, it's very high cost, are happening every day in our institutions. And how do we transform all of those to different ways? So I'm going to turn it over to Berhanu. She's going to talk a little about the concept digital learning ecosystem. Then I'll come back and tell you more. Berhanu.
Thanks, Amir. All right. So, those challenges are, I would expect, common challenges across, many institutions. The changing of the student population is not just only a CSU problem, but in the CSU that gets magnified because we don't have a lot of resources to support the large-sized students. So the digital learning ecosystem has been changing gradually, over the years, right? Technology, not only the devices they come to school with, how we deliver this, courses in the classroom. Just last week, I received a request from 2 computer science students who want to do their, project in AWS cloud. We're not, entirely set up for that, but that's an indication. It's not only the campus infrastructure, but it's, other infrastructure that is going to be become part of the new digital learning ecosystem. In the context, particularly for CSU Fullerton, majority of our students are commuter students. We have very small percentage of students that are residing on campus. 90-somewhat% of our student population are commuter students. So if you look at, the context, the learning communities, it is they learn when they are on campus, they learn when they are outside of the campus. What is the role of, parents, other coaches and motivators in having an effective, learning outcome for students? So in all of this, the way we communicate with the students, the way we communicate with their parents, the way we communicate with if they have like a employment, externally, the way we communicate with all those stakeholders is going to be different. That's why, when you think about the automation, how it's going to be able to help, with some of this engagement practices, because if we do it the old way, there are not enough resources to be able to accomplish all of those. So at the core of this is, what is, the learning outcome for the students, effective, right? Are the students being motivated in the right way? Are they being engaged in the right way? A lot of times when I'm walking around the campus, all you see is the students on their, on their little phone. They don't even make eye contact. So, a lot of the stuff they want to do is, through this device. what are the things that we can do for them, to be engaged by utilizing, the devices of their choices, the communication method of their choices. The behavioral changes, the students, the way they learn, the way they want to do their work, is, different, not the typical traditional, classes. I'm sure in most institutions there is a lot of flipped classes because, flipping a class would, put some of the learning responsibilities on the students. They can access material ahead of time. Flipping a class is not necessarily putting syllabus on the learning management system, right? Put the actual content, put the actual lecture on the system. So with all this, potential learning outcomes and the way the ecosystem is changing, we need to think about how we're going to engage the students. Student engagement, it has to be a challenge for many institutions. They have done a research on student engagement definitions. So student engagement is how much time and effort are they putting into their studies and other educational purposeful activities, right? That's part of their engagement. In IT, Amir has led, the effort of putting, high impact practices into some of the curriculum, working with, faculty. So the students will stay engaged in those learning activities. And the other aspect of student engagement is how our institutions deploy resources, organize the curriculum and other learning opportunities to get students to participate in activities. So, the learning, the classroom learning, the outside of the classroom learning, their sense of belonging on campus, has a lot to do with engagement. If they don't, have that sense of belonging, on campus, the students are kind of detached. It becomes a transactional thing, right? The whole learning experience is not going to be engaged. They will come, take a course, go, separate from the university, completely. So the research has been done and trying to, categorize institutions by, what type of institutions we have in higher ed. So Gary Pike and George Koo have done a research on student engagement, and they have identified institutions to be 7 types: diverse but interpersonally fragmented, homogeneous and interpersonally cohesive, intellectually stimulating, interpersonally supportive, high-tech, low-touch, academically challenging and supportive, and collaborative. I'm sure you could, associate, institutions, your institution with one of these, different, types of institutions. I'm sure, when I look at CSU Fullerton, we are very diverse, but interpersonally, fragmented, makes sense because, like I said, a lot of our students are, commuter students. And, when you look at institutions, it may have one or more, attributes of this, different institutions. So given the population of the students we have, given the challenges we have, how do we keep the students engaged, on campus learning, doing their academic goals in the number of years we have them on campus? So robotic process automation. We need to have, technology to apply to improve the student engagement. So, robotic, process automation, the name sounds like about robots. It's not necessarily about robots. It's, the concept of, robots, using to define what software automation is like. So with software automation, we would like to enhance the engagement of students on our campus. So because of the size of students, there are a lot of mundane activities that the students need to perform, which can be made more efficient if we apply the proper technology and technological solutions. So when we talk about robotic process automation, what does it mean? So Gartner actually has published several articles about robotic process automation. One of the attributes of robotic process automation is it is a combination of user interface recognition technologies and workflow execution. Right? These are things that can be automated using software. It can mimic how people are doing things using mouse and keyboard and clicking on different screens and be able to perform particular transaction. So can robotic automation be able to accomplish those tasks? While it's called robotic process automation, this tool is not physical object, right? It can be paired with other tools, business process, management systems, or artificial intelligence. So automation is a practice that has been around for a long time. What makes automation different now is when you apply artificial intelligence to automation, because it can go a step farther to accomplish a particular task. The automation also can handle application-to-application interactions. So, if you look at the automation options, diagrammatically, these are, the different systems or tools, resources that would come into play. When you automate, it doesn't have to be this, major, grandiose, tasks that need to be automated. There are a lot of tasks that are performed by people that can be automated, that can be made more efficient. So one option to look at is, how can we automate to assist employees with their tasks, to make them more efficient with what they do? What are the other things that could eliminate, possibly an employee task? I don't want this sound to sound like, we have the ability, we're going to be replacing people in our institution with, the way things are, we're not going to be able to eliminate jobs. We can eliminate tasks, but we are not going to be able to eliminate jobs. It can take data from structured and unstructured data sources. With technology, we're not going to be limited, with what kind of data can be accessed by, artificial intelligence. And in the middle of all of this, how do you apply the proper artificial intelligence to these components so that, some tasks can be improved? Artificial intelligence and machine learning, a lot of times, people use them interchangeably, but, they are not, necessarily interchangeable. One is a part of the other. Artificial intelligence is the broader field of, computer science, where, the machine is going to be able to, digest a lot of data, make intelligent decisions, about what it needs to do with that data. The machine learning piece is where the machine is going to learn, certain things over time, and now it's going to become smarter in performing a particular task, right? So a lot of AI and systems, it does take a long time for the machine to learn, what kind of questions people are asking, what kind of answers need to be provided. So it's not a magic box that will understand everything, on its own. It needs some kind of assistance to provide some intelligent, feedback so that they can perform better. This is again how machine learning is being utilized to make artificial intelligence systems smarter. Artificial intelligence, is a must-have, these days. If you look at this, there are all these, different components that artificial intelligence can be applied to, IoT, data processing, tangible robotics, the physical robotics, conversational interactions, decision support, process automation. All these are ways in which artificial intelligence can be applied to, generate a business value, to make education better, to graduate students faster. The business value for us is going to be in that perspective. Gartner did a survey of CIOs, and between 2018 to 2019, the number of CIOs who have employed AI in their implementations has gone up from 4% to 14% between just 2018 to 2019. And Gartner also predicts by 2020 that number is going to be jumped, triple. It's going to go approach, 50% of the interviewed CIOs think they will deploy some kind of AI in their environment. So artificial intelligence is here, some in small scale, some in large scale, will be deployed. A lot of times when we hear artificial intelligence in machine learning, what comes to mind is IBM Watson. Watson is not just that thing we saw on TV, on Jeopardy, right? It has a lot of components. Watson Analytics, Watson Explorer, Watson Knowledge Studio, Watson Developer. These are different components that Amir will talk about later in the architecture, how we were able to use the Watson Cloud to automate some of our systems. The main thing with Watson we get is cognitive computing, which is natural language processing, and the artificial intelligence, right? With those functionalities being available with Watson, it helps with automating a lot of processes. One example where Watson was implemented and effectively used is the teaching assistant at Georgia Tech. So they use Watson as a backend to develop a system that can do that can perform teaching assistant tasks. A lot of the students, they didn't recognize what they were interacting with was a robot. They thought that teaching assistant was actually an actual person, helping them with the teaching assistant. To create that perception, you can imagine how the system needs to work, effectively be able to answer the questions appropriately for the students to walk away with the impression that they are actually talking to a person, not to a machine. So, with that, I want to bring you to, our Cal State Fullerton implementation of some of the automation we have begun, and what, we envision to do in the future. So initially using the Watson backend, we try to automate some of the transactional systems. If you go back to the number of students, 40,000 students, if even 5% of them are asking simple questions, they have to go line up somewhere to ask simple question. It is not efficient for them. It takes a lot of resource time to answer, simple questions. We have a campus about, 268 acres. We have multiple locations on campus. Even for a newcomer to the campus, to know where places are, where things are, that could take, a significant amount of time from the limited resources. So, location, operating hours for some of the things. So we want to automate those, and we developed, the application to answer these basic questions. And it is, providing that service to the students. the objective is, like hopefully we'll, enhance the system in the future to answer financial aid questions. What's the status of my FAFSA application? What additional information do I need? We think, with the architecture, you'll see in the architecture how we develop a middle layer, orchestrating layer that is going to help us scale it up, as much as we need. Bring new data sources from, different systems. All those are going to be possible because of this middle architecture that we created. We call it the the Tuffy service provider, which is going to interact with the backend, with various backend systems. When we developed the Tuffy, it's a mobile app. It's available. We developed our own mobile app, which is called Fullerton. It's available in the App Store, in the Android store. So students can download their mobile app and be able to interact by text or by voice with the Tuffy application. So if it is a question, where is the library, that can be typed or that can be said by voice using our web application. With that quick introduction about our app, I'll turn it over to Amir to talk about the architecture.
Thank you, Berhanu. So the Tuffy, just to, we wanted to have a system that is for students easy to use, more of a conversational system, because the new generation, they like the Siri. They call, hey Siri, do this. We want to say, hey Tuffy, do this. And Tuffy is our mascot. So we figured the Tuffy is really related to that mascot. So we want to create a mobile app, as Berhanu indicated, that ability to do conversational, okay? And they wanted to do it with artificial intelligence and machine learning. So what we did was, we wanted to set up a system that really is not based on any other dependency. So what we did with this is, if you look at it, we have the students at the top, the architecture, and then we have what we call a user layer. So we created a multi-tier infrastructure. Then in here, we have two middle tier, as Berhanu indicated. We have IBM Watson services in the middle. Now that could be replaced. If you like Amazon services, using Lex or any of the services they have, we can replace that. If we want to use the speech to text of the Microsoft is better, we can change that. So what we wanted to be able to interchange technology in this infrastructure. The technologies between Watson, Amazon, Microsoft, Google, is all and Salesforce are all changing all the time. And we wanted to be able to either use any of these things or all of them together in order to do that. On the right-hand side, we wanted to also have a layer, Tuffy, a service provider, to be able to get to the authentication and things we do for students. And then the bottom is all where systems are going. So we have a bunch of systems going, all of these transactional systems. What is, for example, we can ask, what is our campus-wide ID? Or what is my GPA? What classes shall I go to? All of those questions and answers can be done from the top, from the students, to the client level, and different type of client. You have Android, iOS, we have Alexa, you can have you have our portal, any of those things can be going through it. So if you look at the next architecture, the students will ask Tuffy a question, which is the elasticity in the middle, and then it goes into the promise stack in the bottom and gets across. I want to show you a demo of this. And, we didn't want to do a live demo. I've done live demos before in my lifetime. and I know how it works. So we have a little video for you guys to see. And then we go to the rest of it.
California State University Fullerton is committed to pushing the boundaries of technological innovation in serving students. One of our newest innovations available to students is the Tuffy chatbot found in the iFullerton app, the student and faculty and staff portal, and even on Alexa devices around campus. Through conversations with Tuffy, students are able to find office locations, contact information, and even operating hours for all major services on campus.
Where is the TSU?
Titan Student Union is located near the middle of the campus. Click the map for directions.
Students can even find out personalized information through their mobile apps after they log in.
What is my campus-wide ID?
Your campus-wide ID is displayed here.
Our Alexa interface allows students in housing, and eventually throughout the campus, to interact with iTuffy in a hands-free way and still get all the information they need. Students can simply load the app on Alexa devices around the campus to get answers to their questions immediately.
Alexa, is the rec center open?
Student Rec Center is open Monday through Thursday, 6 a.m. to midnight, Friday 6 a.m. to 10 p.m., and Saturday through Sunday 8 a.m. to 10 p.m.
Alexa, who's the mascot?
The CSUF mascot is a very good-looking, intelligent, yet humble elephant named Tuffy the Titan.
As a CSU-wide initiative, we are also working on a Cal State University info skill that can respond to general questions about all of the 23 campuses in the CSU system.
How many students are there at San Diego State?
There are about 36,000 students at San Diego State University.
How much is tuition at CSU East Bay?
Full-time tuition for undergraduate students who are California residents is $6,984 per year.
These new services are just a small example of the work that we do throughout CSUF to ensure that our students have the resources to continue to reach higher.
So, give you a little bit of a usage for this. We have about 1,500 conversations on the first day of class. So students are really start using this. They, as you know, it's 4,000 conversations during the first week of the class, and since January, about 10,000 interactions and this is for about a month about transaction IDF. We get the burst at the beginning of the semester, then it slows down, and because the students are coming on campus. The goal of iTuffy is really to provide a positive experience for students. One of the things I want to talk about, how many of you guys work on chatbots before? Okay, if you look at the chatbots, most of you understand chatbots. Most of the chatbots are about question and content. Okay, a lot of questions. If you look at Siri, can only ask certain questions, right? If you get to 10, you can confuse Siri really easy in 2 minutes, right? Because it doesn't have all the answers. So because when you look at artificial intelligence, you look at knowledge base, right? It's trying to build a knowledge base and machine learning, and look at the context. When you look at all of those together, you can only answer certain questions. And then as you build in more questions, you build in more content around this. So our goal is to make sure that those questions are answered. We're also looking at different way of providing conversational to this. So when I look at the systems of future, I'm looking at 2 systems: transactional systems and conversational systems. That's it. All the user interfaces we're looking in the future will be conversational systems. We're not looking at transactional systems. Because on the students, they want to say, I want to drop my class. Which class? Marketing 443. You have Marketing 443, you have ISTS 224, you can go down the list. Which one you want to drop? I want to drop Marketing 443. I want to add a class. Now, if you want to add a class, how many steps does it take you to go to add a class? How hard it is? It's too many. It's way too many. Transactional systems are not for our digital native of future. The conversational systems are here to stay. People are using it every day to order pizza, to get a Starbucks coffee, to do everything from A to Z. Even if you go to Universal Studios, you use conversational system to be able to communicate to where the rides are, what's the weight of the rides are, and so forth. So this is the future. So we want to make sure that is a stay for them. We also wanted to train our student to ask the right question. The difference is you cannot keep track of all the content and the questions together. We want to bring it together. So we want to tell the students, in order to add the class, these are the 10 questions we're covering. You can use them any variety of these things, but you can add a class using these type of questions. If they don't ask the right question, eventually we'll fix it, and eventually we use machine learning to make it smarter as we go along. But this way, a student can still do conversational system. One question can answer it can be lots of different transactions. So we want to have a positive experience for them. We also want it to be a city for our students, right? We want to be able to do iTuffy's under, and we want it to be able to do more, as we said, automated campus directory, scheduling. For example, one of the things we're working on is the following. We are looking at triaging student advising. So you can ask about student advising, any type of student advising question. Once the iTuffy does not know the answer, we want him to ask him, do you want to schedule a real advisor for you, not a virtual advisor? And we can actually go to the advisor schedule and schedule an advisor for you. So by driving home, you can ask a question about a school advising and make an appointment at the same time before you get home. So that's the goal we have. How do we really make it a better? And you can even raise it for class, look at your financial aid status, look at anything you do on campus. The goal of us to make life easier for our students to engage better. And we're going to integrate most of the system to it. Again, using a mobile app and Alexa. So automated conversational system, that future of this, personalized companion to users. And also we know who you are. That's another advantage of this. We know exactly, when they log into iTuffy, we know who you are. So we can actually have a personal space for you. Do you know you have a hold on your class schedule? You're unable to register until you go and pay that library fine. So when you log in, we can give you personal space. You don't have to wait until 11 p.m. when you're trying to register for class to have a hold and you don't know what to do with it. So the other thing about iTuffy is also 24/7. How do we really, today's learner, we looked at the data. Where is the largest data where they log into the campus, the transactional systems are, special learning management system, from 11 p.m. till 2 a.m. These are our students. Where is your services being offered? 8 to 5. How many of you guys have beyond 8 to 5 services for our students? Very little. You have it, but it's very little. It's still there. It's not zero. But it's 2%, 4%. Majority of graduate students are there. 5 to 10, right? Majority of our computer students are there. 5 to 10. Where are services? Majority of them, 8 to 5. So this will allow a change of paradigm for our delivery of services across the university. Future work, again, personalized play, graduate advising, financial aid advising, be able to put Alexa, so we create a skill for Alexa, and we're trying to do that, the same thing. If you notice, we're creating a CSU info, so we're creating a skill for parents to be able to entire California University systems to ask a question about information. Just to find a fact for something, it'll take you 20 clicks to get to something. Just to know how many students they got in a campus, how many clicks does it take to do that? Way too many, still. Because on searches, I love searches. But you require a skill to do a search. You can't just get any search done, right? But you can ask a question, simple questions. How many students Cal State Fullerton has? And be able to get the answer. So our goal is, how do we really move that to different directions? How do we change paradigms along with the intelligence and the new technology coming in? Like that. Any question, any comments? Yes.
I'm at San Bernardino.
Yes.
Campus. We have a similar initiative. What can we do to up the interaction with students in a similar way? I think we're also working. I've seen little parts of our chatbot. Every time I run into the word artificial intelligence, it's like that red flag goes up for me, because when it actually comes time to implement it, I don't see a lot of training data going in or people trying to classify information. It's been people writing basically if statements.
So let me tell you about this. Personally, I've done a lot of research on this. Okay. So personal research. When you're looking at artificial intelligence, right? You're really looking at the concept of deep learning. Okay, what it is basically take it, and I'm looking at conversational piece of this artificial intelligence. When you look at a conversation or natural language processing, you're looking at it. What it does is it takes knowledge base, any kind of knowledge base, you want. It takes the context and the way the language works together to give you an answer. Give you an example of this. When you say my nose is running, right? You think you really is, if you just take it apart, in a shallow learning, it's about is your really nose running, right? Or when you're looking at deep learning of this, it really means that you may have a cold, right? And may have a cold means that the context and also you use the knowledge base to be able to bring it all back. So when you look at artificial intelligence, that knowledge base could be fixed. When you look at machine learning, that knowledge base gets improved every time. So as you increase the knowledge base, you can be able to answer questions very differently. So that's about conversational thesis. I hope that answers your question.
I think we're in agreement. I was just thinking in a practical sense, I'm seeing people actually working on the chat bot, and I don't see them adding to a knowledge base. It's like their actual work hasn't been, or the language processing, yes.
Right.
Natural language processing, that's a whole different category.
Right.
You outsource it as well, it looks like. It's like, no, that's going to be something, you've already done it better. I can send text out and get some sort of processing back.
Right.
It's just been the actual, like, no, how do I teach it what questions to go answer?
Most of the teaching piece of it, unless you have a knowledge base. For example, when you're looking at Watson, right? Watson have a medical knowledge base right now. So you could actually subscribe to it. So it has a lot of question and content and has lots of boards already built into it. When he did the Jeopardy, they actually took Wikipedia and loaded into Jeopardy. That's what they could get it into it, right? That was the knowledge base. So on a campus like us, what we're doing is we're actually building the knowledge base, right? As we go along, we're building a knowledge base. So we are looking at almost every month and kind of enhance that knowledge. So we are training it moving forward.
Okay, I guess that's what I'm looking for. It's like, is that what it is? Is trying to maybe even structure it so it fits into that?
Because we don't have, there's not higher education. Every campus is different, first of all.
Yes.
We are, if you look at 3,000 schools within the nation, you got 3,000 flavors, right? So every campus is different. Our question and answers are almost different. Even there's some core that are saying.
No, sure. We have You Achieve. I saw that up there. We're all PeopleSoft, so there's some overlap there. Sure.
Yes.
Well, I'll hitchhike on that a little bit. Larry Conrad, Berkeley. So we had Deloitte in a few months ago to give us a presentation on RPA. Mm-hmm. The way they presented it was more, we set up, forget the product they're working with, but they're working with somebody down the peninsula. And so they set up these banks of personal computers. And basically what they were doing was generating the transactions for the transactional systems. That was the interface, right? And their pitch was that, there's tremendous opportunity to save money. I mean, I was interested, I heard you say that you weren't going to eliminate any jobs. Their pitch was you can eliminate a lot of jobs in particularly the finance area. So I guess I'm fuzzy now about just exactly what this is. You said you're using Watson to build a knowledge base. Well, so what's being fed in? You're not front-ending transactional systems, I take it.
We are. If you look at it, we're back-ending transactional system. We're not front-ending. There's a difference. Okay. So what they're doing is a little bit different than what we do. What we want to be able to, right? We have so many students right now. So if you look at eliminating job, right? We got this much work. We got this much resource. There is still tremendous amount of work that can be done. So what we want to do is eliminate things that are easy to be eliminated and make RPA for it. Okay? Instead of, for example, lots of students taking 20-minute slot from advisors. Give you an example of that, right? For simple questions. Okay? How do I change my grade from A? I got a D in one class and now I got a C. I want to be able to grade forgiveness, right? I want to be able to do that. Well, you go fill out a form here, or you got to do the steps to do this, right? We had over 6,000 requests when we analyzed some of our unstructured data that came just for that question. And they went and burned 20 minutes of advisors' times in order to go get that questions. I'm just giving you an example. So our goal is how do we use robotics? How do we automate some of these things ahead of time? So when a student needs to go and says, I want to be able to change my grade, We have all the steps already be done. We can have a knowledge base to respond to them, say, here's the 3 steps you need to follow.
Okay, and not to get too far in the weeds, but Watson has this ability to take this unstructured data basically and load it in and then make some sense out of it.
Yes.
What I'm not getting is, well, where's the unstructured data that you're loading into Watson? Where's that coming from? Or are you feeding it in
I'll give you an example.
by hand?
Give you an example of that. What we did was, this particular example that I gave you, we had over 120,000 advisor notes. So what we're doing to build our advising triage is we're using advisor notes into the Watson, getting the result, and then building our triage system to it. So that's how, if you talk about transactions, that's unstructured data, we're getting that, right? So those are the things never existed before.
Right, thank you.
Yes.
Amir, so like who have been your key partners like on campus, not necessarily externally, but because clearly I'm guessing you haven't done this with your own budget exclusively, right? You've got to have other people in the boat with you. So who are those people that you've had to get in the boat with you, both from the support and not just financially, but even from a budget standpoint?
From a budget perspective, we have worked with the provost, the student affairs officers, and us. Those are the 3 partners that we use. And lots of these things, we use a consulting firm that help us to develop some of these things and partner with a consulting firm. But most of it, we start a lot of things fresh because, when we went to IBM, I'll give you an example of this. IBM said to us, it'll cost, $2 million for us to come and just have a small IBM Watson chatbot. And I said, that's fantastic. You can go pitch that to USC, but we are not, USC, our acronyms start with CSU, not USC. So I think you're looking at it backward. So this is what we did is actually I went through and I got trainers by IBM Watson and I brought the trainers in from them to train our people so we can do it ourselves. So we do a lot of these things ourselves to be able to actually, bridge the budget moving forward. I hired somebody from a student affairs called chatbot coordinator. It's a new position that we just hired called chatbot coordinator, that their job is engage the campus and be able to look at the chatbot and be able to look at the content and questions and be able to update it all the time. So the other things is, and what are the students are saying? So we're looking at that. That person also look at some of the unstructured data to see how we really make that change. It's a process, as I said, in most of the institutions, but it goes across everyone. Yes. It's called Thought Focus Study. It's one of our Thought Focus. Yeah, TOUTH. Thought. Okay, I'll send it to you. I'll send it. Yes.
Thank you. I'm kind of curious, for the personalized information, like what's my student ID, how do you authenticate the person that's talking when they're using an Alexa device that's just randomly across campus somewhere?
We have 2 concepts we got across the board. Either you're authenticated or non-authenticated, okay? And non-authenticated, we have public data. It's only social, lots of things that you can do. When it's authenticated, you can't do it in a common areas. Basically, you have to use your connections to be able to authenticate it to that device. So we are, and also if you notice here, we are not using voice to release any of the FERPA data. So campus by ID, your grade, all of those things. We don't want you to sit here and your parents see, what's my grade? And they say it loud and everybody hears in the room. So we were very careful. We also giving pins, capability to use pins, so for security purposes. So at a certain point, we come and ask for a pin.
Okay, so depending on the classification of data, you're saying like, oh, you have to actually text with me in the app that you've authenticated to already.
Yes.
Okay.
Yes.
The other thing I was curious about is for structured data, like what's my GPA? How many, first, I imagine for some systems like PeopleSoft, there's existing ways to interface with that. You just leverage that. How many new APIs have you had to create, or are you planning on creating to get access to structured data that's already there but siloed?
Right. Our goal, for example, we're going after Moodle. our learning management system Moodle. So we're trying to get everything. What's my assignment today? Right? Those are all available on Moodle. So some of those things we are actually directly working with these things. So we have people going to those APIs. We asking API like crazy. We want to say, I don't know the number, tell you the truth, but I know that we are actively adding APIs that layers. If you look back to here, we're trying to add that whole layers in the middle. The data feeder layer. See that? That's coming. We keep actively adding APIs to it and testing it. Yes.
So I'm going to guess that you're not using Alice and AIML in the back end because you're talking about unstructured language. So if you're building the knowledge bases, and right now you're doing it from the student perspective of student services, but you also had that example earlier where it's been done for teaching assistants, and coming from Sac State, where we don't have a graduate program in geography, we don't have teaching assistants. So how would your faculty then be able to go and create those knowledge banks for it? Because obviously it's going to need to do web scraping at some points in time, and then you're going to have.
We haven't got that far yet.
Okay.
So that's our next step. How do we use it for teaching assistant? And something we want to engage in next year to look at. We are looking at some online programs, because some online programs that are large online programs, how do we create teacher assistants for them to be able to do that, part of that, and integrate it to Moodle? That's the goal.
And that's going to be working with the faculty, or
Yes.
that's going to, okay.
Yeah, working with the faculty. Any other question? Yes.
So, what's ultimately somebody has to pay for all this. So, what's the investment that's needed to make something like this work? And in particular, maybe an upfront. And
there are
non-recurring versus recurring
right.
operation.
There are two investments happening to these things. One is an OpEx, and the OpEx of these are, if you look at those IBM Watson services, so every time you go, there's IBM service called Conversation. Every time you go to Conversation to retrieve something with question and content, that costs you money. So there are really, they're sub pennies, but they're still, you get those. Every time you do a speech to text and text to speech, it costs you money. So all of those that we have a bucket of dollars that we use for those conversational, those tiers that get in the middle. And that's another reason we set up this way, because IBM was getting a little bit expensive. So we want to be able to go to different vendors, because again, we noticed that the Alexa does a better job, Amazon does a better job with text to speech and speech to text than it does IBM does. Conversation is still, IBM is better than any other services. So we want to do that. So the OpEx, what we have been putting about $50,000 a year on those services right now. $50,000 a year. Okay, that's what we have on those services. And that's our OpEx allocation to this. And so far it's been very good. So far we've been using about $25,000 to $30,000 of it, not even fully. But again, we are amping up. So I'm thinking that will go up, and that's why we want to be more economical. And IBM also dropping prices. That's another thing. This is a competition with all these services are. What I love about them, compete. Our price comes down. So I think that's probably about, I would say, under $100,000.
What about staff support?
Staff support, we have one chatbot coordinator that does full-time. We have one half-time and one full-time. We have 1.5 time that is, I would say, coders that does these, okay? And I would say probably a couple of half-time. So about 2.5 to 3 FT, just to get across. And a lot of them not 100%, except our chatbot coordinator, everybody's not 100%. Just want to let you know. Because when we develop APIs, some of these APIs develop in other systems and we can reuse them. So I would say about 3 FTE. That's to be fair across the board. And again, as you ramp up, it's higher. When you ramp down, it's a little bit lower.
Sure. And not to beat it to death, but what about CapEx and one-time money?
CapEx, we spent about $100,000 in the first year.
Okay.
And we are doing about $50,000 to $100,000 on a CapEx on a regular basis. It's not just to pay the consultant, pay, here and there to get everything going. We didn't use millions, just want to let you know. So it was not millions. And people talking about, we are not USC, but
Everybody wants a distance 6 right now.
even in admission process.
So I hate to cut in this great conversation, but we're right at 12 o'clock here. So again,
All right.
thank you guys
All right,
very much.
thank
Thank you.